Hello, welcome to BackToCoding. In today's practical, you will learn how to test your Android app. For a better understanding of this video, I highly recommend you to check out the video of concept related to testing in the description below. Also, don't forget to hit that subscribe button and bell icon so that whenever I publish a video, you get notified instantly about it. For this practical, you won't build the simple calculator app yourself. The complete project is available at this URL. You can find the project Simple Calc here. Click on this clone or download button and click download zip button. The download starts. After you have finished downloading it, unzip the Simple Calculator project folder. Open the Simple Calculator project into Android Studio. If you face any issues while syncing the app, you need to make changes to the app level's Gradle file as shown here. Expand the app and Java folders, then expand the com.example.android.simplecalc test folder. This folder is where you put your app's local unit tests, and calculator test is the sample test class created by Android Studio for you. Open calculator test class and let's examine it. As you can see here, the only imports are from org.junit, android.test and org.hamcrest packages. Now, what is @runwith, @smalltest, the setup method, and all is already being explained in my Android testing concept video. If you still haven't checked it, I highly recommend you to go ahead and check it from the description and then come back here. The add to methods is an actual test. The first line is a call to the add method. You can only test methods that are public or package protected. The second line is the assertion for the test. Let's run the test. Right click on the calculator test class and click run calculator test. All the tests in the calculator test class run and here it shows test passed. Now change the assertion in add to numbers method. Instead of 2D, use 3D. Run the test again. This time the assertion fails, since 3 is not equal to 1 plus 1. Change it back to 2D and run again and you will see it runs perfectly. Now let's add more tests for the add method. Add a new method to calculator test class called add to numbers negative. This test method has a similar structure to add to numbers method. It is public method with no parameters that returns void, and it is annotated with @test annotation, which indicates it is a single unit test. Run all the tests as before. As you can see, the add to numbers negative test still passes even though it doesn't contain any code. A test that does nothing is still considered a successful test. Let's add a line to invoke the add method with a negative operand. D indicates the number is of type double. Add an assertion with assert that method. They assert that method is a JUnit for assertion that claims the expression in the first argument is equal to the one in the second argument. The assert that method is used with matchers. Matchers are the chained method calls in the second operand of this assertion is equal to. In this case, the assertion is that the result of the add operation -1 plus 2 is equal to 1. Let's run it. And it works perfectly. Let's add one more unit test for floating point numbers. Again, a very similar test to the previous test method, but with one argument to add, that is explicitly type float rather than double. The add method is defined with parameters of type double, so you can call it with a float type and that number is promoted to a double. Run all the tests as before. This time the test failed. This is important part of the error message. Arithmetic with floating point numbers is inexact and the promotion resulted in a side effect of additional precision. The assertion is technically false. The expected value is not equal to the actual value. The question here is, when you have a precision problem with promoting floating arguments, is that a problem with your code or a problem with your test? In this particular case, both input arguments to the add method from the calculator app will always be type double. So this is an arbitrary and unrealistic test. However, if your app was written such that the input to the add method could be either double or float, and you only care about some precision, you need to provide some room to the test so that close enough counts as a success. So change the assert that method to use the close to matcher. For this test, rather than testing for exact equality, you can test for equality within a specific delta. In this case, the close to matcher method takes two arguments, the expected value and the amount of delta. Here the delta is just 2 decimal points of precision. That's it for this video. I hope you enjoyed this video. Please give it a thumbs up and share it with your friends. And don't forget to check my other videos which can be helpful to you.